Let's take a look at the change data capture event trigger as it's done in Apex. In this case, this trigger only has the after insert event, and you can see this is acting on not the reward balance custom object, but the reward balance change event itself, as this change event suffix is how to indicate this trigger acts on the event bus. Just for knowing, the event bus is essentially the messaging system that temporarily stores and broadcasts events. When events are read from the event bus, they're essentially being received via listening, as opposed to asking Salesforce for data. In the reward balance change events class, I have an extremely simple trigger here that counts the number of events as the number of changes being done. Changes are defined in this case as a change in state occurring. This could occur from a record insert or an update, so long as the state is changing, that's what matters. Admittedly, this is a bit of a trivial example. It only counts the number of events. In the test class for reward balance change events, I assert against this count of changes as a means of ensuring the count is accurate. Is this useful? No, it's not. The point here in regard to this change count statement is that you could really put any logic you'd like here, and it runs asynchronously. There's no interface to reference like there is in a queuable job, and yet there's no limitations to concern yourself with as far as input types, the way there would be with future methods. This appears, at least syntactically, exactly like a regular Apex trigger, but the difference here is that it runs in a separate context. It doesn't occupy the same limit space. To prove that, even within an Apex test, the limits get reset, take a look at the debug statement, both within the trigger and the test class, that looks at how many DML statements have been consumed. There is one statement within the event trigger and another within the test. When looking at this from the debug log, it shows that no DML statements have been consumed from the event trigger, and that's because it runs in a separate context. This is fascinating because it means that all of the data that goes along with the records, all the field values, is available via the event trigger context. And yet, we didn't have to do much of any special setup on the object. One thing you will have to do if you want to experiment with this more functionally, and not just within a test, is go into the org and enable the given object for change data capture. Make sure you do this first if you're wanting to use a change data capture event trigger via Apex. For production use, this is necessary. On the other hand, the enable change data capture method from the built-in test class allows you to test Apex without having to have that configuration done. That's how I've delivered it to you here, actually, without having any enabled change data capture for the given object as a part of the course example materials installation. Building event-driven architectures is a large topic, all its own, and for complex implementations of this, you'll want to seek out additional resources, including those here on Pluralsight. Until then, feel free to experiment with this example, and note the different calls that are done in the course examples. I've also included a URL at the top of the test class that links to the Salesforce documentation on change data capture triggers for further reference.